This is lesson 2.2, Earth's Interior. Your notes must include the quest title, the learning goals, and the vocabulary. At the end of this lesson, you will be able to identify the layers of the Earth, describe the characteristics of Earth's interior, and identify the properties of Earth's interior using the Earth Science reference tables if you are in the Regions class. Below you will see the vocabulary, and they are lithosphere, crust, core, inner core, outer core, mantle, plasticity, asthenosphere, and MOHO. All of this should appear in your notebook when I see you during class. Let's begin. The crust is the outermost layer of the Earth, mostly composed of rock. There are two types of crust: the oceanic crust and the continental crust. The oceanic crust is composed of basalt. That is an igneous rock. It's underneath all of the oceans that exist on Earth. The continental crust is made of granite. Granite also is an igneous rock. It makes up all the continents and larger islands that exist on Earth. The continental crust is thicker, but has a lower density compared to the oceanic crust. The mantle, which is this orange part here, is composed of solid rock. It is divided into the upper and lower mantle. The upper mantle is called the asthenosphere, because part of it flows. The temperature is extremely hot within the upper mantle that allows for solid rock to flow. The lower part of the mantle is solid and is known as the stiffer mantle. It does not flow as easily as the upper mantle. The outer core, which is highlighted in yellow, is liquid. It is composed of iron and nickel. And the small center that I just highlighted is known as the inner core. That is a solid matter that is composed also of iron and nickel. One thing to remember as you're moving from the crust to the center of the Earth, your depth is increasing, your temperature is increasing, and the pressure is increasing. So the highest temperatures and the most pressure can be found in the inner core. To develop a model of the inside of the Earth, scientists gathered evidence collected from seismic data. I'll write that here, seismic data, which is data collected from earthquakes. So all of these lines that you see in this diagram right here represent primary, secondary waves that were produced once an earthquake released its energy. The Earth's inner and outer core is composed of nickel and iron. Describe the difference between the inner and outer core. The inner and outer core are both made of the same material. However, the inner core is solid and the outer core is liquid. Let's review some more. The crust is composed of two parts, the oceanic crust and the continental crust. If you look at this image right here, you would notice that the oceanic crust is underneath the ocean and the continental crust is underneath the continents. This diagram also shows you where the asthenosphere is, which is that plastic mantle that we just spoke about. The mesosphere is just a name to say that it's an inner layer. The lithosphere, which we just talked about in class, is the solid surface of the Earth. Okay. If you are in the Regions class, you're going to continue to watch the video, and if you are not, you may stop here. Earth Science Reference Table Practice. This table shows the inferred properties of the Earth's interior. Remember, scientists have not been able to pass certain layers or surpass or dig through certain layers of the Earth's interior, so they were only able to use seismic data to infer or to gather indirect observations about what exists underneath the Earth's surface. So let's look at this table and let's try to come up with some answers to these questions that I have put up here. We will have more practice in class on using this table. The first question is, what is the density range of the mantle? If you're looking for the density range of the mantle, you're going to, let me just zoom in for you. You're going to look for the word indicated density, and it is right here. Okay? So we are focusing on the density range for the mantle. The mantle, including the plastic mantle, is this area right here, highlighted. The density range for the mantle is between 3.4 grams per centimeters cubed to 5.6 grams per centimeters cubed. I'm going to write it down for you. 3.4 to 5.6 grams centimeters cubed. Great. Next question. What is the temperature range of the inner core? Again, you're going to look at the table. I'll zoom out so you can see the chart. Temperature is indicated at the bottom. The inner core is located right here. I'm going to highlight it in red. So you're reading downward. So the temperature is indicated right here. And the temperature for the inner core is between 6,000 Celsius to about 7,500 degrees Celsius. It's a good estimate. The next question. Which crust has more density, the oceanic or the continental? Look for the section on the graph that's indicated density. And let's read together. The continental crust is 2.7 grams centimeters cubed, and the basaltic oceanic crust is 3.0 grams centimeters cubed. So the oceanic crust is the crust with the most density. I'll just circle the answer there. Following question. What is the pressure range of the outer core? The outer core is highlighted in green. Here's your outer core, and we're looking at this part of the table. The pressure is measured in million atmospheres. So, the pressure for the outer core, the range is between 1.5 to about maybe 3.1. So I'll just write that on the graph, on the answer. So 1.5 to 3.1 million atmospheres. Now let's look for relationships within the variables: temperature, pressure, depth, and density. Let's analyze the relationships. The first question, what happens to pressure as depth increases? So depth increasing, you're looking in this direction. Okay? So let's look at the crust, the mantle, the outer core, and the inner core. So we begin reading down here. So as depth moves from 0 kilometers all the way to 6,000 kilometers, I'm looking at the pressure chart indicated right here. I see that as I'm moving from the crust to the core, the temperature is increasing. As depth increases, temperature increases. So that is a direct relationship. As one increases, the other increases. Next question. What happens to temperature as depth increases? Again, we're looking in this direction from the crust to the inner core. And temperature is indicated down here. So as depth increases, we're looking at the red now, from 0 to 6,000 kilometers, temperature is also going to increase. So that means that is another direct relationship. As temperature increases, or temperature increases as a result of the increase in depth.